Many of you recommended the Yeston RTX 56GB low profile, and I finally have one here. Unfortunately, the Yeston 3050 is thicker than other single-slot GPUs. It won't fit the original case or my 3D design for the RX 6400. It fits my dual-slot case, but we want this build to be as small as possible, right? Today, I am designing a new 3D case and bracket specifically for the Yeston RTX 3056GB to fit the Lenovo Tiny 5 series, such as the P330 Tiny and M920X. Can a custom ventilation case solve the size and heat issues? The Tiny 5 only supports a 50-watt GPU when paired with a 35-watt CPU, but this Yeston is a 70-watt card. So is it possible to make it work? Let's find out. The Lenovo Tiny PC I have here is a Lenovo ThinkStation P330 Tiny. This model supports a 65-watt CPU or a 50-watt GPU, like the NVIDIA Quadro T1000, when a 35-watt Intel CPU is installed. If you don't want to get involved with 3D printing or design, you can choose an NVIDIA Quadro single-slot low-profile GPU. It fits this tiny PC model very well, and you can even purchase a GPU bracket for it without needing 3D design or printing. Alternatively, you can buy a mini PC with a new Ryzen CPU and built-in Radeon 780MI GPU if you are truly seeking a high-performance PC for daily use. Honestly, this DIY project involving 3D design and the challenge of installing an RTX 3056GB on a Lenovo Tiny is meant for hobbyists and DIY enthusiasts who love to push the limits for fun. The Lenovo ThinkStation P330 Tiny that I have here comes with a 65-watt CPU cooler and a chipset Southbridge heatsink. The 65-watt CPU cooler also has metal contact with the VRM chips on the motherboard to cool them, which is a feature not found on models like the Lenovo M720Q or Lenovo M920Q. For the CPU, I have installed an Intel Core i7-9700T, which is a 35-watt CPU. A cool feature of these Lenovo Tiny PCs is that the RAM and M2 SSD are located on the bottom of the motherboard. For the SSD, I have a 1TB Crucial P3 Plus installed and 2x16GB for a total of 32GB of DDR4 3200 MHz RAM. To install a GPU, we need to remove the PCIe expansion card bracket. If the GPU is longer than an NVIDIA Quadro T1000, we also need to remove the front antenna bracket as well. There is no option to mount a standard PCIe bracket with this tiny PC case, so I need to remove the GPU bracket and design a 3D printed bracket for it. Previously, to remove this GPU bracket, I had to remove the entire fan shroud to access the screws. But now, I found an easier way. Just put the screwdriver through here at a slight angle and turn it gently. The screws can be removed without taking off the fan shroud anymore. Here is my 3D case design. I designed a new ventilation case by expanding the ventilation area to be larger than the original top cover for both the CPU and GPU fans. I extended the case height by 5 mm to make it fit the Yeston RTX 3050 low-profile GPU. I also designed a GPU bracket and a stand for this setup as well. I 3D printed the case with ASA filament to ensure it won't deform from the GPU heat. And here is the 3D printed case. Instead of using glue to stick the case parts together, I designed a screw mechanism. I made the case to work with 3x3x5mm female threaded insert nuts and M3 screws to secure the top cover to the front bezel using 3 screws. The female threaded insert nut can be inserted into the 3D printed case using a soldering iron. So now, let's attach the 3D printed front bezel to the 3D printed top cover and secure it with 3 screws. Now, the new 3D printed ventilation case for the Lenovo Tiny 5 is ready to use. Since Lenovo only made the GPU bracket for NVIDIA Quadro single-slot low-profile GPUs to fit these tiny PCs, I 3D designed and printed one for my Yeston RTX 3050 low-profile. So now, let's install the GPU into the 3D printed bracket. Alright, now the GPU is ready to be installed in the PC. I added some ventilation holes to the 3D printed bracket to allow the GPU to blow hot air outside the case. Here is the PCIe x 16 riser adapter for the Lenovo Tiny 5 series. We need this adapter to install a PCIe expansion card on these tiny PC models. Now, let's install the GPU into the PC. Make sure the PCIe riser adapter is firmly snapped into the PCIe slot on the motherboard. Secure the PCIe riser adapter to the PC case with a screw, and then secure the 3D printed GPU bracket to the PC case with a screw at the back. After installing the Yeston RTX 3050 low profile in the Lenovo Tiny 5 PC, we can clearly see that the GPU height is about 5 millimeters taller than the original PC chassis, so we won't be able to close its original top cover with this GPU installed. So I designed a new 3D top cover to solve that problem. The top cover also supports the slide to remove feature, just like the original one. The original top cover uses a single thumb screw on the back to secure it, but since my 3D printed case is plastic, it won't be as strong as the metal top cover. So I designed it to be secured to the PC chassis with two screws, one at the side that secures to the 3D printed GPU bracket, and one at the back using the original thumb screw hole. Now the whole setup is complete. Before we run the CPU and GPU stress tests and gameplay tests, let's preview the final build. I also made the STL3D model files available on my Creality cloud. If you are interested in doing it yourself, please check the link in the video description. Since I love to use my 16-inch portable monitor with a small mini PC setup like this one, I use a DP to USB-C cable to connect my PC to the monitor. This way, I can power the monitor and send the display signal through just a single cable. My Lenovo ThinkStation P330 Tiny came with a 135-watt AC adapter. It should be fine with an NVIDIA Quadro T1000 installed, but since I installed a 70-watt GPU, I might need a higher wattage AC adapter. I have a 300-watt Lenovo AC adapter here, which is probably overkill for this setup, so you might want a smaller AC adapter, like a 170-watt version, which is more compact and easier to carry. I've also designed and 3D printed a vertical stand specifically for my custom case, allowing the mini PC to be placed vertically or horizontally as needed. Alright, now let's turn on the PC. With the Lenovo M920Q Tiny, when an RTX 3056 GB is installed, it always faces a CPU power throttle limit, and we typically use the Throttle Stop app to fix it. However, on this Lenovo P330 Tiny with the new BIOS update, Throttle Stop is no longer able to disable BD Proc Hot. Because of this, I am not using Throttle Stop with this setup. Now, let's run a GPU stress test with Furmark. The max GPU temp recorded while running the stress test is 74 degrees Celsius. Now let's test whether CPU power limit throttling occurs in this Lenovo P330 Tiny PC with a 70-watt GPU installed. For the testing method, I use CPU-Z to run a CPU stress test and GPU-Z to run a GPU stress test at the same time. As you can see right now, the CPU power draw goes up to 53 watts and then down to the PL 135 watt limit normally, while the GPU power on the GPU-Z sensor tab shows a 70-watt load for the GPU TBP. The results show that this PC model still handles the CPU and GPU without throttling under certain loads. However, based on my actual usage, during prolonged gaming, the PC gets hotter and CPU power limiting still occurs, just like on a laptop. I found a simple way to prevent the CPU power limit completely on this system. Based on my experience, when the GPU load is around 70 watts or more, since it can spike up to 75 watts or 80 watts over the PCIe slot, the PC is put into a CPU power limit state. After I limit the GPU power to run below 70 watts, the PC can run without the CPU power limit. To achieve this, I use MSI Afterburner to limit the GPU power to 90%, keeping the GPU load stable between 60 watts and 65 watts. Some folks may have a better solution by undervolting the GPU core to get better results with minimum performance loss, but since I don't specialize in that, I'm sticking with the method that is a safe bet for me. Now, it's time to check real-world gaming performance for this tiny gaming PC setup. The first game I want to test is God of War Ragnarok at 1080p, medium settings, with DLSS set to balanced and no frame generation. We've seen the gameplay achieve around 70 frames per second. Right now, I'm using MSI Afterburner to limit the GPU power to 90%. The GPU power is around 60 watts to 65 watts, and the CPU power is around 35 watts. The game is playable without CPU power throttling occurring, and the PC is not crashing. However, as you can imagine, the system fan noise is as loud as a gaming laptop. Now, let's move on to Doom: The Dark Ages. At 1200p, since my portable monitor has a 16:10 screen ratio, I set the game graphics settings to medium, DLSS balanced, and no frame generation. We've seen the gameplay achieve around 65 frames per second. The CPU temperature is around 71 degrees Celsius, and the GPU temperature is around 72 degrees Celsius. The next game that I want to test is Cyberpunk 2077 at 1200p with the medium graphics preset, but I changed the DLSS setting to balanced with no frame generation. I'm using the built-in game benchmark for this game. Once the benchmark run was complete, it showed that the gameplay achieved 77 frames per second. The last game that I want to test is Shadow of the Tomb Raider at 1200p with medium settings and no DLSS. I also used the built-in game benchmark to test this. At the end, the results showed that the gameplay achieved 73 frames per second. That is all for the video. Installing a 70-watt Yeston RTX 3050 low-profile GPU in a Lenovo Tiny 5, such as the P330 Tiny or M920X Tiny, is a bit of a challenge, but it is possible. By combining software and hardware tweaks, such as creating a 3D printed ventilation case and using MSI Afterburner to fine-tune the GPU power, you can make it possible for the system to run most AAA game titles with playable performance and manageable temperatures. System fan noise is a general issue for all Tiny setups, and even laptops. I hope you found something helpful in this video and enjoyed it. Thank you for watching.